Hello, this is James Keene coming to you from Binary Mechanics Lab. Welcome. Today let's talk about the physics standard model, the Requiem edition. Physicists mourn passing of the standard model. The standard model may be reviewed in terms of its two main pillars, its elementary particles and its mathematical model. Both of these standard model pillars were seriously flawed and out of date during their several decades of effort to become a credible and viable physics theory. But as we pay our last respects, alas, it was not meant to be. Number one, the standard model elementary particle list reflects, firstly, very clever efforts by many physicists to summarize and condense an enormous amount of experimental data. And secondly, the methods used to collect that data, namely particle collisions at ever increasing energies. Second, the standard model mathematical models are proclaimed as self consistent, quote unquote, while clearly exhibiting fatal physical, logical, and mathematical incoherence due to their now discredited assumption of continuous space-time, rendering pages of impressive equations simply inapplicable at the more microscopic binary mechanics level of fineness. As a consolation, much of this math will continue to produce useful approximations at the atomic level, as Newtonian and Maxwellian math is still used beneficially at even more macroscopic levels. Let's talk about physics theory profitability. It may be conceived as ability to generate hypotheses, observations, and experiments advancing physics knowledge. Perhaps a look at the present balance sheet is appropriate. You know, expenses versus income. On the expenses side of the balance sheet, useful items may be salvaged from the standard model particles. Start with standard model particle layoffs as shown above. Fully functional universe requires only electron and d down quark color variations and their antiparticles and neutrinos. And in other videos, we showed that this reduced number of particles can be accounted for completely by three binary numbers, the modulo 2 spot coordinate of those particles. Looking at expenses, number one, at present, binary mechanics has derived the entire list of standard model particles from three binary digits, or a single number 0 to 7, the red X above. This desirable jump in parsimony goes a long way in cleaning up the expense side of the ledger. Two, the scalar Higgs field doublet appears to be a vague reference to perpendicular spot unit pairs that implement the strong force bit operation in binary mechanics and thereby determine mass of fermion particles in proton and electron bit cycles. But alas, the Higgs boson is an incomplete, primitive treatment of the subject. In any case, the Higgs field and associated boson no longer have heuristic value to guide future research, being based on obsolete math assuming continuous space-time. Third, on the expenses side of the balance sheet, with the binary mechanics time development bit operations, the gauge bosons are simply not needed. Right here, the middle X. As might now be evident, using observed particle interactions to define primary forces has exhibited limited scientific merit. The story that they've been trying to sell has been that each new variety of interaction must be mediated by quote unquote exchange bosons, which are no longer needed with the universe humming along as always, thank you. Thus, four more expensive particles can be mothballed, perhaps sent to a physics museum, further reducing overhead. That's really good news. However, photonic and gluonic light bits, called L bits, are keepers as one of two bit types in spot units, but not as gauge bosons per se. In summary, physicists may substantially cut expenses without losing any product quality regarding universe functionality. Now, what about the income side of the balance sheet? Binary mechanics appears to be the current leading fundamental physical theory, according to the "what have you done for me lately" criterion. That is, more advances equal increased income. For example, we have the first ever calculation of Planck's constant from first principles of a comprehensive physical theory. And we've derived some half a dozen other basic physical constants from first principles. That's a lot of income. In sum, in the overall balance sheet, decreased expenses and increased income may produce a double-barreled net increase in fundamental physics profitability. The author does not know of any physicists who are fully content with the standard model. Nearly all want to modify it, extend it, or go beyond it. Well, the good news is you don't have to worry about it much anymore because, well, today it is being buried. They never thought their sickly quantum theory was going to lose.